Howdy, howdy. This is Mr. Potter. In our previous lesson, we talked about how we could use arrays as kind of a dynamic memory allocation, where we can decide how many variables we want on the fly. So first thing I want to do is I want to kind of illustrate that. I want to make a list of, say, a certain number of random integers, and I have no idea how many I'm going to have, so I'm going to prompt the user for that information. So remember that whenever I want to prompt the user, I need to set up a scanner. So I'm going to import java.util.scanner and set up a scanner for system in. So scanner in gets new scanner for system.in, and then I want to go ahead and prompt the user. So I'm going to system.out.print how many integers. And then I'm going to get what the user types in through in.next, but I want to parse it as an integer. So I'm going to say int num values equals integer dot parsent for whatever I get through in.next. So this kind of foregoes storing it as a string and then trying integer.parsent to kind of compare them at the same time here. And then once I've got this, I can go ahead and set up my array of values. So I'm going to set up a string array, or excuse me, an int array called vals or nums. Gets new int array, and the size is going to be num values. And so if I type in 30, then I'm going to have 30 values in here. If I type in 300, then I'm going to have 300 values. And then I want to set up a real quick loop for int I gets 0, I is less than nums dot length. Remember, for arrays we don't have nums dot length parentheses because it's an instance variable, not a method. I plus plus, and I'm going to go ahead and say num sub I is going to get, and I can use the math.random times 100, and whatever I get out of that I want to cast as an int. So I'm going to take random integers between 0 and 99. I'll go ahead and tackle 1 on there just to make them random integers between 1 and 100. And then I can go ahead and go through the list one more time. And I get 0, I less than nums dot length, I plus plus, and I can go ahead and system dot out dot print num sub I plus a space, just to have, actually I can even do nums comma space. And this is actually going to illustrate an issue that we have with this. There's going to be one small problem with this. We'll talk about it briefly, but it's not the focus of today's lesson. The system.out.print line, just to polish up the output. So if I run this, pardon me. If I run this, it's going to prompt me how many integers, and I can type 50. And then when I hit enter, it's going to create a list of 50 integers. So it's creating 50 random integers, all between 0 or all between 1 and 100. Now the point that I wanted to make out is this little comma right here, because we're printing the nums and then a comma, even when I get to nums.length and I print the 50th number, which is in position 49, I'm still going to have that comma there. So usually what I'll do is I'll kind of polish it off by 1, and then just at the very end I would do num sub nums dot length minus 1, and that takes care of it. This is something called the fence post problem, and it's one of the traditional output issues that we have to deal with in a first-year computer science course, because whenever we use loops to print something out, say if I want to print out 30 numbers, I need to find a way that I end up getting this transition character in between all of my data values, but I don't want to make sure that transition character doesn't show up either at the beginning or at the end. And so I kind of need to treat one of the endpoints as separate. So this is, to solve the fence post problem. But that's not really the focus of today's lesson. The focus of today's lesson is really twofold. One is this idea that this is dynamic. I actually type in how many integers I got, and if I wanted to put a larger number like 500 or even 5,000, I could do 500 numbers here. And so I actually, whatever value I type in, I have the capacity for storing that many numbers. Of course, restricted to the memory on my computer, but that goes without saying. So the next thing that I want to do is I want to talk about how I would go about searching for a particular value on here. Notice that all these numbers are between 1 and 100, so I'm pretty sure I could find a 36 in here. As a matter of fact, where is it? I thought I saw a 36 around here. I'm sure I can find a 36 if I look hard enough. There's a 36 right there. So I know there's a 36 somewhere in this list. And if I'm using a large number like 500, then I certainly should be able to find a particular value in there. So what I'm going to do is I'm actually going to create a method, public, called linear search. And what I want to do is I want to search for a particular value, which I'll call my target. And what I want to do is I want to return the position that I find it in. So I'm going to be returning an integer position, which box it's in this particular data set. So I want to get the target, and I also want to give it the list. So I'm going to do an int array called list and the target that I'm looking for. And what I'm going to do is just set up some method of going through the list that I have and finding the particular object that I want. So what I'm going to do is I'm going to set up a loop. So for int I gets 0, I less than list dot length I plus plus, and if list sub I is equal to target, then what I want to do is I want to return I. So if I find what I'm looking for, then I'm going to find it in a particular spot. And I'm going to tell the caller of this method exactly which spot I found it in. With the caveat that maybe it's not in my list. Now keep in mind the only thing that I can give back is an integer. I don't want to try and give back a string or toss an exception like we've done in a previous problem. I want to give an integer, and what we found in a lot of the methods that we've dealt with that return integers is that our error case ends up being a -1. So if I make it through this list and I make it past this point, then what's happened is at this point the target is not in the list. So we need return a -1. And so we just make sure that we actually return an integer, because Java won't let us declare an integer method without returning an integer at some point. And so what I've done is in our main method, I've got this method that actually it stores all these values in the array, and it prints out all these values in the array. And then what I can do is I can do system.out.println. I can say target plus say target val, which will need to be an integer that I declare. Let's say a 37. Shows up at index plus, and then this is where I want to have my call. So it'd be linear search with my list, which I called nums, and my target, which is target val, plus a period because English. And so I'm going to run this and make sure I declare it correctly. Semicolons at the end of our statements are a nice thing. Stop. So what was my error? It said linear search. Oh, because it needs to be static. That's right. This actually is a class method that I need to run because it's being called from a class method called main. So this needs to be a static method. So if I run this, how many integers? If I do 500 integers and it's looking for a 37, it says it found 37 in index 144. If I look at this, so looking for 37 in position 144, pretty far down in here, but yes, there's a 37 right there. So if I run this again, but this time I run it with a much smaller window, say I only want to run it with 5 integers. Notice that none of these integers are 37, and so I get my error message. So 37 shows up at the index of -1. I can run this another time, try and get something a little bit more middling, like 20, and it doesn't show up there. I want to run it one more time. Say with a 20 again. Still doesn't run. And of course, there's basically a 1 in 5 chance or something similar to that I'm going to find a particular number in that range of 20 randomly chosen integers. It's a little bit different than 1/5, but pretty close to it. So, main 2 ideas that we're talking about today. One of them is this idea of dynamic allocation. The idea that I can declare an array and in the midst of the program tell the computer how much memory I need, and it'll declare that many variables for me, which is a very, very powerful tool. It's one of the things that we can do to make sure that our program only uses the memory that we need. And then the second idea that we had here was this concept of a linear search. The idea that I can go through the list one item at a time, asking each item in that list, are you my mommy? Are you my mommy? Going through and trying to find something that matches our target. And if we find it, we tell the user exactly where we found it. And if we didn't find it, we need to give some type of error message, some error value that satisfies our return type int, but also indicates that something went wrong. Remember that an index starts at 0 and goes up to length -1. An index can never be negative, and so returning a negative value is our big warning that something bad happened. So we've got the idea of dynamic memory allocation and the idea of a linear traversal, the idea of going through step by step in an array looking for a particular value. Of course, part of the issue that I have here is that this data is completely random, but also that there's no order to this. There's no sense or semblance of it. So I physically have to go door to door looking for a particular value. It certainly would be convenient if this data was in a certain order, so I know once I went past a certain point, there's no sense in continuing to look. And that's what we're going to address in future videos this week. So, once again, this is Mr. Potter. Thank you for watching. Have a great day.